Welcome to the third final review video. This video will be on reciprocal, or sometimes we call them rational equations. Rational equations are all equations where you have an x on the bottom. In this example, the simplest strategy to use is cross multiplication. You can only cross multiply when you have a single fraction on both sides. So my first move is going to be to rethink of this 2 as a fraction, which is basically the fraction 2 over 1. When I have a fraction on this side and a fraction on this side, only 1 on each side, separate but an equal. You can do what some people know as the butterfly method, or cross multiplication. Cross multiplication is the actual word that you should use in your video. Basically, you multiply the diagonals and you set them equal to each other. Don't put a multiplication or an addition in the middle. Make sure that equal comes straight down. If 2x equals 5, then x clearly equals 5 over 2. Here's some vocabulary that you might want to pause and make sure that you note down. The second problem is, again, just a simple cross multiplication problem. The only difference is you will have to distribute in this case, because when you multiply 3 times x minus 5, you're not just multiplying the 3 and the x, you're also multiplying it times the 5. The best way to avoid a common mistake is to write that step out explicitly. 3 times x minus 5 using parentheses. Some people will just distribute in their head. If you can do that without making an error, you are welcome to do so. Once you've distributed, this should be 3x minus 15 equals 2x minus 1. When you subtract 2x from both sides, you get x minus 15 equals negative 1, and then adding 15 gives you an answer of 14. On the next problem, you cannot cross multiply, and the most common mistake people will make would be to cross multiply in this direction. You'll end up with a mess because you'll have two equal signs. Before you cross multiply, you will need a common denominator. In order to get a common denominator, you should think about what x and 2 can both be turned into. These are both factors of some bigger term. The easiest term to use would be 2x, because you multiply x times 2. Sometimes, however, you will want to use a smaller term than that, especially if you have like x squared or two coefficients that are both numbers. Be a little strategic. In this case, I really recommend thinking backwards. I know that my goal is to have the same denominator on both fractions, and I know that that denominator should be 2x. What do I have to do to turn this first fraction into a 2x denominator? Well, simple enough. I would have to multiply times 2, and if I do that on the bottom, I have to also do that on the top. So this will turn into 2 over 2x. Similarly, for the second fraction, what would I have to do to turn x over 2 into something over 2x? I would have to multiply times x. X times x on the top is going to give me an x squared. And 8 stays the same on the other side. You do not need to have a common denominator across the equal sign. I can now add these together, add the tops, keep the bottoms. They're not like terms, so I'm really just going to write x squared plus 2 on the top over 2x. And I'm going to reimagine the 8 as a fraction, which would be 8 over 1. I can now cross multiply. I have a single fraction equaling another single fraction. When I cross multiply, 1 times x squared plus 2 is just x squared plus 2. And on the other side, 2x times 8 is 16x. This is a quadratic equation. Make sure that you use that word. We have now transformed a reciprocal equation into a quadratic, which means you probably expect to have two solutions. Before you can find them, you need to move everything to one side, which leaves you with x squared minus 16x plus 2 equals 0. In an ideal world, I would be able to factor this, and a times c would be 2, b would be negative 16. Unfortunately, you can't factor this, so we're going to have to use quadratic formula. Here's what it looks like. X equals negative b would be positive 16, plus or minus the square root. B squared would be 16 squared, and it turns out that 16 times 16 is 256. Minus 4 times 1 times 2, which is really just minus 4, all over 2 times a, which is just a 2. This gives me x equals 16 plus or minus the square root of 252. over 2. And 252 can be divided by 4. If you think about it, 16 times 16 is 256, which means 4 times 64 is 256, but we subtracted a 4, so this is actually 4 times 63. And so we would take out that 4, and we would get 16 plus or minus 2 root 63 over 2. Can divide the 2 from both, which gives me 8 plus or minus the square root of 63. And there's actually a sneaky thing you can do here, because you can simplify 63 one more step. 63 is 9 times 7, and 9 is a perfect square. So this is actually 3 root 7, and the final answer would be 8 plus or minus 3 root 7. If you happen to notice up here that this 252 can also be divided by 36, and you could have used that right away to simplify this out. Either way would have been an acceptable way to arrive at the same answer. Pause the video here and work out the 3 problems on the right-hand side. When you're ready to see the answers, press play again. Here's answer A and B. Here is answer C. If you flip the page, we'll do just 2 more rational equations, starting with this one. By now you should start to recognize our first step is going to be to get a common denominator. I'll move a little more quickly this time. My common denominator is going to be 2x, which means I must have multiplied the first equation times 2 and the second equation times x. When I collect my terms on the left-hand side, this gives me 3x plus 2 over 2x equals x over 1. When I cross multiply now, I get 2x squared equals 3x plus 2. When I bring everything to one side, because this is a quadratic equation, we get 2x squared minus 3x minus 2 equals 0. If I set up my snowflake method, the top would be 2 times negative 2, which is negative 4. And the bottom term would be negative 3. This one I can factor, luckily. So factoring this gives me terms of negative 4 and positive 1. And negative 4 can be simplified with the 2 on the top to be 1 over negative 2. So my factored form would be x minus 2 times 2x plus 1. When I split these out into 2 solutions, I have x equals positive 2. And then I have x equals negative 1 over 2. If you don't see where that comes from, do the middle steps out, one by one. For example 5, our first step is the same as example 4. It's going to take a little bit more work. A common denominator for x plus 2 and x minus 5 would involve multiplying them together. In other words, the first fraction is going to get multiplied by x minus 5 on the top and the bottom. At the same time, the second fraction is going to be multiplied times x plus 2 on the top and on the bottom. The 1 is going to stay by itself for the moment. When I do this, because the work is so long, it's usually nice to collect them into one fraction right away. On the bottom, you have the product of the 2. The order in which you write these 2 terms doesn't matter as long as you have parentheses around them. On the top, we have x minus 5 times 1. If you distribute that, that's just x minus 5. And we have 2 times x plus 2, which if you distribute is 2x minus 4. Watch out for a subtraction sign. If there's a subtraction sign here, we would have to distribute a negative 2, which would flip some signs. That will be a common mistake for many people. As it is, though, this all equals 1. And I'm going to combine like terms on the top and FOIL on the bottom. So on the top, we are left with 3x minus 9. On the bottom, we have x squared minus 5x plus 2x minus 10. And it equals 1 over 1. And I wrote it as a fraction because my next step is cross multiply. When I cross multiply, we get x squared minus 3x minus 10 equals 3x minus 9. Bring everything back to one side means subtracting the 3x and adding the 9. This is not something that can be factored. Think about it. 8 times c is too big. So quadratic formula, here we go. Negative b, plus or minus the square root of b squared, minus 4 times a times c, which turns into a plus 4, all over 2a. 36 plus 4 is 40. I know that 40 can be divided by 4, leaving 10 inside, so this is the same thing as 6, plus or minus 2 root 10 over 2. Simplifying both coefficients gives me 3 plus or minus the square root of 10. That's your final answer. Pause the video here while you work out the 2 on the right-hand side. Press play when you're ready to see the answers. Here's D. And last but not least, here's E.